Good evening, everyone. Today I want to tell you something about Microsoft Fabric. I wrote a blog at the ending of last year. Today I want to walk through the use case I used for that blog and take you with me in Microsoft Fabric. Let's go through the contents of today's presentation. First I will do a little introduction. I will tell something about Microsoft Fabric itself, about the product, where Microsoft is coming from. Then we will scope a little bit into Microsoft Fabric for data science, the blog and the use case, and I will give a demo about that. Also, I want to look into what Fabric has on the roadmap for next year, to see what we can expect also, especially on the data science part and data engineering part. And of course, I've reserved some room for questions. Okay, for me also a lot of new faces, so I thought it would be nice to introduce myself. I have been with Sogeti since April of 2023. I live in Nijmegen, beautiful city in the east of our country. And I am in the AI community, specifically AI integration and automation. I have a background myself in data science. I've finished a master's in that. And yeah, here are some hobbies. I like to play football, I like to cook, also make my own pasta. And I love cats. This is my cat, Pasha, that always tends to make friends when you say you love cats. A bit about my experience. Although I have did a study in data science, and most of my experience comes from data engineering. I have worked as a data engineer at Menzies for 3 years. Worked with Azure a lot, so Microsoft product. Worked a lot with Databricks, Azure Data Factory, also Power BI. And that's also a nice bridge to the subject of the day, Microsoft Fabric. Yeah, so let's talk Fabric, because Fabric is like an evolution of Duo's tools. It was released during the Microsoft build in 2023. They have been rolling it out until now, actually. And a lot of new features have been made available in a beta environment. Well, what is Fabric? At the core, it's an all-in-one integrated data platform solution. What is really new about is that this is a software as a service solution. So it is, you don't have to use Azure anymore. I think only to deploy it once, but then it's all managed within in Fabric. It is AI Copilot powered, which is of course very exciting. And it is a persona-based experience, and that's also what I meant with the all-in-one integrated data platform, is that, different data personas can work together on the same platform. Yeah, so here you can see the different personas as well. So the you have the data factory persona, data engineering, data science, also a data warehouse. You even have features for real-time analytics. Of course, Power BI. And the data activator. And the data activator is, you can use it for like event-based triggers. You use a lot in combination with real-time analytics. So when a certain value from your real-time data stream hits a specific threshold, you can trigger an action. Yeah, and it's all, the data fundament beneath this is OneLake. The great thing about OneLake is that you have all these different personas and you use all type of different engines and programming language, but underneath it is all the same data format, which is a Delta Lake Parquet format, which is of course a highly compressed data format, which is great for analytics and data processing, etc. Yeah. So what I said, so also you have of course the Spark engine. So you can use Python, R, but yeah, you can also talk to it via a more data warehouse type of experience. We're not going to focus on that today because that is not really the data engineering experience, but more the data warehousing experience. But it is possible. So yeah, that's also maybe a nice topic for another time. Yeah. So again, today's scope: data factory, Synapse data science, and data engineering. We're going to look at those features because that are the features that I also used for the use case. The use case So last year in the summer, I did a use case. It was a fictional use case, but I used real-world data. I used an open source Airbnb dataset, and the dataset contained Airbnb listings, so apartments with the prices of the apartments and all information about the neighborhood, the location, etc. And what I wanted to do is, do like an end-to-end solution, ingest the data, do some data engineering on it, and at the end also develop a machine learning model. Also touching the most of the phases from the machine learning life cycle. By using real-world data, I can come as close as possible to get a good sense of where Fabric is about. About the dataset, I already explained. So it is a dataset made available via French data website, Open Data Soft, so that's an open API key. Or not, you don't even need an API key, you can just get it. Over 1 million records. For today's demo, I have, we're going to use not that many data because then we're going to do a lot of waiting, which we don't want here. Over 88 columns, and also like the real world challenge. The data is just also messy and it has like null values. It has a lot of description columns. So yeah, a lot of challenges to surpass. I think, yeah, so I'm gonna explain a bit of the process for the demo. So we're gonna do several things. So we're going to ingest the data using Data Factory by doing an API key, and then we're going to land the raw data, which are JSON files, into a landing zone. And after that, we're going to transform the data, do some data exploration, and at the end, the real fun, at least for data science, from a data science perspective, is building the model. And I'm going to take you through the process, and shall show you all the components that Fabric has to offer, both in data engineering and in data science. It's demo time. Yeah, as you can see, it really looks like Data Factory. It has not all the functions, but for my use case, that all the functions that I needed. So yeah, here I do like a copy data, the classic copy data activity in Data Factory. I get the unique cities, and after I get the cities, I loop over all the cities because the API had like a rate limit, so you couldn't get all the data at once. Because we are doing a demo, I chose to only load in the data for Paris and Amsterdam, because otherwise it will take so long, and because it's gonna take time, I'm not going to run it right now, but I'm gonna see, because that's one of the things that you have in Fabric is the monitor. I maybe can see my run of this morning, and then we can just walk through it like that. Yeah, so here, so this is, yeah, it is a shared workspace, so you can see everyone's runs, and everyone can alter each other's notebooks and pipelines. So that is something that that might need improvement in the future for Fabric. So here's the pipeline. I ran it 2:30 this afternoon to check whether it worked. Yeah, and as you can see, it is just Azure Data Factory actually, right? So this I can look at the outputs. So here I got all the cities, but filtered only Paris and Amsterdam, and then here we can look at the get data pipeline. So what I did here was copy the data, and then because it's a JSON file, I want to convert it to a Delta format that it could be nicely loaded into the data lakehouse. Let's see, this is... I'm not sure whether I can see the notebook. No, but what we can do is we can, so if everything you have opened comes in here, so you can easily hop back and forth between your work. So let's take a look at Lakehouse experience, which is for data engineers and data scientists. Is I think the most appropriate way to store data, because you want to also work with the messy data, right? Not just the data that is already fully prepared for reporting. So what we just have done is that we loaded the data in, the raw data in, and after we load it in, we convert it into a Delta file with a notebook. So here you have all your files. So like the file underneath, and you can easily create a table. And I think that is something new, is that you can just go like here and do load to tables. So you don't even need code to create like, I think it's called like a Hive metastore on top of your Parquet files. So what we just have done is like the first step. So we got the data, first we loaded into store, so a bit like the medallion framework kind of operation. So it were all JSON files, and after that we converted those JSON files into, let's see, yeah, so into, Delta Parquet format. And now we can, so like this you can take it, this always takes a couple of seconds. Yeah, so here we can see the actual data set. So as you can see, we have some messy data. For example, this is not something we can use at the moment. We're going to handle that in the data engineering process, data feature engineering. We also have empty values. That's all types of thing we have to deal with. And a lot of columns, and we're not going to use all of them, of course. Let's go to the next logical step of the process. We have the data, so let's do some data exploration. So for that, so now we are really going into the realm of maybe data analytics, data science. And what I used for that is a notebook, because with Python. And I think this is the first notebook we are looking at. And what I found, because I have a lot of experience also with Databricks and Synapse, and then it takes quite a, because then you have to manage your own infrastructure. So then you have to spin up a cluster a lot of the times if you don't have pools, and then it takes 3 minutes before you can actually run some code. And in this example, most of the time it takes only a couple of seconds. So I guess like behind the scene there are already pools running and you can just use resource from there. But it seems like that's still maybe also depending on your subscription, that it's also dependent on the availability of the cluster. So sometimes you wait longer, sometimes faster. Because yesterday I did it and I waited like 5 or 10 seconds, and this afternoon I waited 2-3 minutes. But let's check out. I'm just gonna run this script to see how much time it takes to get a compute node in action. Yeah, so it took 12 seconds, which is okay if you compare it with a normal realistic scenario that you have to spin up a cluster. Which in my experience, I never used pools, so I always had to spin up a cluster before I could actually work. What I did, because data scientists, data engineers, a lot of the time work with, in my experience, with PySpark, but data scientists like to work with pandas. So Spark also has something nice with this pandas PySpark. So I used that here, so then I could just use like the pandas syntax and the pandas functions, but leverage the power of Spark, of parallel computing, etc. So for now, I'm just going to run all the cells. and just walk you through the process, what I've done. First I listed all the columns. Here it might take some time because it has to load in the data from the data lakehouse, but it shouldn't take that long. Yeah. Okay. So here I did like a describe to get some, well, just to get an overview of the data, what is going on, averages, median, that type of information. That's always the first thing you do. What I also did is that I created a heat map because this was also you do also the data exploration part to know during the feature engineering part what are the wise decisions to make. And because I'm also going to work with the linear regression model later on, I wanted to see whether there were in the data set themselves there were like a lot of intercorrelations. So that's why I created a heat map. And what I saw, which makes sense, is that for example, availability in the next 30 days, availability in the next 60 days, 90 days, 365 days, that there was a lot of intercorrelation there, which makes sense. So it doesn't make sense to have all these variables in your data set because they tell you all the same thing, basically. And also with the reviews, we also saw a lot of intercorrelation because you have a lot of different review metrics. You have a review of the room, a review of the neighborhood, and well, it seemed like that when an apartment scores good on one metric, it also scores good on the other metric as well. Here I did like a pairing. And then I saw, okay, what were the combinations of for which variables were correlated with which other variables. Let's take a look at the time a little bit, that we don't get stuck here too long. Then I did some other stuff. Also some visualizations. So it's just to review also. So this is, it is a bit the same as what you have with Synapse notebooks and Databricks notebooks. Only, you don't have to manage the underlying infrastructure yourself, which is nice. And you have a bit more you have some extra feature. You can see your lakehouse here, etc. Okay, so I came up with some conclusion that I had to remove some review score variables, the number of beds, remove these two availability scores because they were very highly correlated, and also all the review variables were also really weird because they were all very high. So I thought that they will not be for a lot of use for me for training the models. Okay, so then we go back to our fabric list. So what we have done now is that we have performed some EDA. Next step is the transformation. So actually, we have a data set, but we want a data set that is ready to put into a machine learning model. And that also means that we can have any, for example, everything has to be quantified. So we cannot have like description columns or categorical columns. We have to dummify them. So that's what we're going to do here. So make it ready for our data set. And actually, what you're going to see here is, a lot of the same, because we did our EDA, and here I'm materializing all those things. So let's scroll down. Now the session started again in 4 seconds. So. Yeah, so of course we have column tables. Those have to be one-hot encoded. So that means that we have that for every categorical value we have a 0 or a 1, instead of one column with just one of those three values. Yeah, we had some date variables that also doesn't work for a machine learning model. Those were turned into days until a certain date. And I also wanted to make use of the location, because what we had, like the geographical coordinates, and I also thought we could do it with city, but then you get just the curse of dimension that you get because there were so much cities in the data set that you get just a too wide of a data set, which makes it inefficient and also less effective. So that's why I wanted to use the longitude and latitude, but so therefore I created polar coordinates. I created a variable that can catch the longitude and the latitude in one one variable, in one metric. So now we come to the fun part, at least from a data scientist perspective, and that is building some models. And you do that also with notebooks in Fabric. And what I wanted to do is I created different type of models, because we're doing, you have in machine learning, you have two a bit harsh, but yeah, you have a regression and a classification problem. We are going to predict prices. So yeah, we're dealing with a regression problem. And I used the following algorithms. So let's go to our experiment. Yeah, so I've created two experiments. In one experiment, I tried to I developed more traditional models, so a linear regression model, a decision tree model, and a random forest model. But I also thought it would be nice to also include a neural network, which is a bit more complex, also requires a bit more computation, also to test the limits of Fabric itself. So I also did a neural net with regression, so a neural net that predicts a real number. So yeah, what was nice that on Fabric is that it really nicely integrates with ML flow, and that's what I'm going to show you in a bit. So what we can do is, yeah, we're going to create an experiment here. So yeah, I need it. So I'm going to run it in advance, because it takes a while, but not really long, because these are not really compute intensive models. And I used the MLlib library, which is a machine learning library of Spark, which uses the power of Spark, so the training of the model is distributed across your clusters, which is nice. So here for this demo, I created an experiment, and if you create an in the data science persona, if you create a notebook, you get the option to get a code template for ML flow. So then you get some. So yeah, here I created a baseline predictor. So just a model that creates the mean value for every record. And yeah, so here you see like how how you can create like an ML flow experiment, and Fabric gives you like a code template, which looks a little bit like this, but I, of course, tailored it for my use case. So I did a couple of things here. I wanted to log the number of rows in the training data set. I wanted to, my main metric is the mean squared error. But I also wanted to track the mean absolute error, because that is a more intuitive way to interpret how good your model is predicting. Yeah, so then I logged in this stuff, and I also, for the linear regression, I logged the R2 metric, because that gives me an impression of how good of a fit my data, my model is to the data set. Okay, so now we are actually training, and there was something in the training set that you could actually in real time. Okay, not here. Okay, so we created our experiment. So this is all still notebooks. So not that special. It just works. You have to, of course, the benefit of not have to take care of the infrastructure. But there is also some additional functionality for data science in Fabric, and that is that whenever you create an experiment, Fabric creates an experiment artifact. Yeah, here. So now this artifact is created, and now we can actually compare the performance of our models. So here you get it. Then I can see a few. So now for every model, we have also the model artifact itself. And here the parameters, but you can also compare them here, like this. And yeah, well, this looks a bit ugly, so let's alter it. So I like, yeah. So this is the mean squared error. I think mean absolute error is nice for comparison to get a good impression of our actual performance, and I like bars. So yeah, now I get a. Yeah, so now so our baseline model, what this model does was just predict the mean value for everything. So that one was 54 euros off. And you can see that our models, yeah, did significantly better. And the random forest is the best one, which makes sense, I think. Well, I'll quickly show you also my neural net performance, because that performance was horrible. But it's nice to show, still keeping it real. And so here I create a lot of models, because you can, with the neural net, you have a lot of hyperparameters, what you call them, and you can try a lot of different combinations. So what I do here is I run a lot of combinations of hyperparameters, and I and here we can, yeah. So what I discovered this afternoon was this, that you can also filter here. So that's nice, because here I have like one with an error of 400 trillion. Yeah, so that also, yeah, blurs the performance of the other ones. So what I can do here is so like. Yeah, so now I have a filter. So what you can see, this is our baseline model, and yeah, they performed a bit better, but not that much better. So yeah, sometimes the more simpler models are more effective. At least in this case, it was. Yeah. So one last thing I can show is that if you. Well, yeah, if you like a model, so in our case, the decision, the random forest one. Let's see, you can create. Oh wait, let's go back. You can create an artifact for it, and then you can also use it in production. I didn't try that. I didn't use it in production, but it's still nice to show how that looks like. Let's go back here. Oh wait, this is the wrong one. I need to. yeah, so I need this one. Yeah, so the run. Yeah, so here, and I think, yeah, you can run, yeah, save run as ML model. And then you could use it, you can store it somewhere, and then you could use it, well, to predict actual values in production. Well, I have not the demo for this, but it's just to show you that, okay, they all also thought about the next step here. Yeah, I think that is the demo. I hope you liked it. I want to, yeah, quickly head back to the presentation for some final, well, some final words. So yeah, so I'm gonna. What did I like about Microsoft Fabric? The ease of use. Firstly, you can just right away start doing something. You don't need to set up any Azure resources. So yeah, you can just get along, or just start playing with the data. Yeah, I thought that all the, especially in the data engineering part, so the notebooks really nicely integrated with the data factory components. Yeah, it was really intuitive. You have like the Power BI experience. So yeah, that was nice. Yeah, of course that you have the software as a service benefits, so you don't have to worry about security. Also, not so much about storage. You don't have to, for example, think about, oh, I have to reserve that much storage. It's just you pay for what you use. Yeah, so and a one-size-fits-all storage solution, so everything is one lake, and then, yeah, it doesn't matter how you talk to it or which engine you use. It's all, yeah, it works all on the same fundament. Yeah, it does also have support for machine learning libraries, for example, MLflow, PyTorch, Scikit, MLlib. I used MLlib and PyTorch, and it created the experiments as well for that, and also the model artifacts. Some cons: workspace management. So as I showed you, you just work all in one environment, and you don't have the granularity to have like your own folders, your own folder with your own map. So it's a bit, with the filters, of course, that solves some of the problems, but not everything. Well, for big AI projects, it might also, it's not ideal. Also because there's also no GPU available. So if you're getting in the realm of creating your own architectures for an LLM, then it's at the moment too limited, at least in my experience. So I would say it is suitable for more off-the-shelf ML algorithms. So scikit-learn, MLlib, so the decision trees, the linear regression, that type of algorithms. And also when you're working together in teams with a lot of different data personas. So with the data, someone who works in Power BI and someone who creates models and someone who gets the data, you all speak the same language, so to say, and you don't have to move between different tools. But yeah, if you have like a really intense, like a real AI team, which really builds models from the ground up, I would say this is not the right solution. Then I would still go for maybe a Databricks, or just even do it on your own, or on your own compute, your own servers. So what is still to come for Fabric? Better session management. Sometimes if you leave your session, it just disappears. You have to run everything all over again. That can be annoying if you develop a lot. There will be features to set timeouts and that kind of stuff, so that you can just set, okay, just let my session live for at least half an hour or something. Copilot integration in notebooks, I haven't been able to use it. It is already there, but we don't have the right license for it, because you need a certain tier in order to use the Copilot. More fine-grained security and workspace management. Notebook integration into an app, so a Power BI app. but then you can have like I don't know exactly what it means, but it seems exciting, so that you can have like a more interaction with the user through notebooks in a Power BI app. Yeah, schema support for lakehouse. At the moment, you have a 2-level. Let's see. Yeah, I think a 2-level hierarchical namespace, but now you're gonna have like a 3-level hierarchical namespace. But that is yet to come. Okay, for the data science part, model endpoints, so that you can talk to it also outside of Fabric. So you can call an API to run your model. That is really exciting, I think, because for some things you might want to work outside of Fabric, but you still want to communicate with your model. So that's nice. Auto ML hyperparameter tuning, and also the monitoring hub. At the moment, you can see data factory pipeline runs and notebook runs, but you cannot see your experiments in the monitoring tab. But that will also be integrated into there.